In this video, we show how to do linear approximation using derivatives and also how to find the differential. And the idea comes from what a derivative is about. We know, suppose you have a curve f of x, then at the point A, if the function is good enough, you can find the derivative, right? And we know the derivative formula is f prime of a is equal to the limit x is approaching a and f of x minus f of a and over x minus a, right? So what it means is that the derivative is approximately this slope of the secant line. And if we just rewrite this expression, this is what we have. So this is approximately the same thing, and this is what we have over here. Or visually, it's easy to see. What it means is that if you have a point nearby, say fx over here, then this is your value f of x. And here is the value on the tangent line, and they're very, very close. So we can say that f of x, the value is approximately L of x, which is from the tangent line. Now, L of x is a linear function, so it's easy to find its value. That way, we can approximate a value with a linear function. So let's look at an example. First of all, let's look at the strategy. How can we actually apply this idea? So at point A, these two values are exactly the same. F of a is equal to L of a. That's one thing. And we are finding a value near a. So x is close to a. So for a problem of this kind, we always need to identify where is the point we can easily find the value of f of a, because we can see that this one over here involves the computation of f of a and also f prime of a. So idea is that f of a and f prime of a should be easy to evaluate, easy to find. Okay. And that way we can approximate, and f of x is approximate. And that's the idea. So let's look at an example. So we want to find this value. Say we want to find, we want to estimate square root of 3.98. And from this function, the function f of x is root x plus 3. And we need to identify two things. We need to identify two things. One is, where is the a value? What is a value? And what is x value? And in this problem, it's given that a is equal to 1. So if you look at it, f of a is equal to square root of 1 plus 3, and that's root 4. That's easy to evaluate, it's 2. Okay. So our x over here should be around a. So x is approximately a. And we see that because we want to find square root, because we want to find square root of 3.98, so it makes that x actually is equal to 0.98. And this is approximately 1. So we can see that square root of 3.98 is equal to square root of 0.98 plus 3. So you can see that x is 0.98 over there. Now we just need to find the derivative. So f of x, we see the derivative is 1 over 2 root x plus 3. So at point A, we have 1 over 2, and root a is 1. So we have root 4 again, and that's going to be 1/4. So what we have now is that square root of x plus 3 is approximately f of a is 2. Let me write it down. F of a plus f prime of a, and x minus a. And we have everything over here we need. F of a is 2, and f prime of a is 1/4, and x is 0.98, minus a is 1. So what we have over here is 2 plus 1/4, and here we have 0.02, negative. Okay, negative. So what we have now is 0.2 minus 0.005, and that's what we have. And that's going to be 1.995. We have another example over here. If you want to find the square root of 4.05, an approximate value, then you can see over here, a is still going to be 1 from this function, and x over here should be 1.05, which is approximately a, which is equal to 1. And we can use the same formula to find an approximate value over there.